Physics homework explanation video. Okay, so today we're going to explain this question about um, weighing a fish in an elevator. So a person weighs a fish of mass m on a spring scale attached to a ceiling in an elevator as illustrated in the figure. This figure. So show that if the elevator accelerates either upwards or downward, the spring scale gives a reading that is different from the weight of the fish. All right. So I've done some explanation right here for you guys. Okay. So as you can see, so let's say this is a person who is in the elevator, right? And this is the fish, and this is the spring. Okay. So as we all know, the tension of the spring is always positioned upwards. You understand? And the gravity upon the fish creates the weight. And the acceleration can either go upwards or downwards because the elevator either goes upwards or downwards. So, as we all know, according to Newton's law, to the second Newton's law, and the third about where the force for every action there is a reacting force that is equal to the. So as you can see, the total net force up on this fish. Let's say the fish is at rest, right? So if there is no acceleration, the forces acting on this fish are mg, that is up, downwards, the gravitational force, and the tension of the fish. And all this net force is equal to mass times acceleration. So acceleration will be zero if the elevator is at rest, but it will change if the elevator starts to move. But this is our formula of net force is equal to tension is positive because we're going in the positive y direction, and mg is negative because we're going downwards negative y direction, and this is all equal to mass times acceleration. So, doing the formula, I'm trying to simplify it. So sorry for my writing. The tension will be equal to mass times acceleration in y, which is yes, the tension. This is the tension. This is the force. So this over here, this mg, will come here and become positive. Understand? So we'll get m mass times acceleration in y plus mg. So if we bring mg out, mass and gravitation, we already have mass and mass here. So ay, this is acceleration in y, this is not going up or down over gravitation for gravity to multiply here, and we'll be left with g, a, and here we'll be left with g. So this is the final formula. Mg is equal to, this is the mg is equal to force of gravitation, which is equal to force of gravitation times acceleration in y direction over gravitational force plus 1. So A is asking us, will the weight read by the scale, change? And in this formula, you can see if we have a high, if our acceleration is high, you can clearly see that our tension scale will read a high weight. And if the acceleration is negative and is going down and slowing down, this tension is here. This tension scale will read a lower weight than the actual fish, because the actual fish weight is force Fg this, and this multiple here will be the one to determine if the weight is going to be lower or higher. And you can see it's gonna be lower if a is negative, and it's gonna be higher if ay is positive. So now for the second question, or B, they're asking us just evaluate the scale reading for a 40-Newton phenomenon. So all you have to do here is just put in the values, and yeah, you get 40.2, and here you get 31.8. Thank you. I think I'm going to restart. explaining. I think I can say more on B. Yes, I need to say more on B. So evaluate the scale readings for 14 Newton fish if the elevator moves with an acceleration of a 2 positive 2 meter per second squared and negative 2 meter per second squared. So here the elevator is moving. So you know what that means? That means our tension scale will show different values. And let me bring down my let me show you how. Alright, so let me explain it. Alright, so as you can see, if we have our tension from the formula I showed above, from this formula, gravitational force acting on the fish, which is mass and gravitation, ay over a, ay is the acceleration, and g is the gravitation acceleration plus 1. So this is a formula we're using to see what kind of measurement our scale will show. So you can see here we have the tension is equal to 40 newtons times. So we're gonna start with positive 2 meters per second. So positive 2 meter per second squared. This means our elevator is moving upwards with an acceleration of 2 meter per second squared. So our gravitation doesn't change, it's still g 9 point something, 9.81. I wrote 9. So it will be 2 positive 2 over 9 plus 1. And we will calculate this and multiply it with 40 newton. And this will give us 48.2. And as you can see, this reading is greater than 40 newton. 40 newton is the weight of the actual fish. But if we're moving upwards, it will be multiplied by this variable here. And the reading will be a weight greater than the actual weight. But if the elevator is moving downwards, it will give us a negative 2 meter per second squared acceleration, and it will be negative 2 over 8 plus 1. And this variable here, will make our tension go less than the actual weight of the fish. So this is what the scale will show. It is apparent that this is less than the actual weight, hence proving our theory with best invention in question A. Thank you. I guess that was very explanatory and very informative.